Hello guys, welcome to your very first C++ tutorial. Now in this tutorial series I am going to consider that you have absolutely no idea what C or C++ is. Oh wait, did I just scare you by saying C? Don't worry, I'll tell you all you need to know. Now here's the thing guys, I have been playing around with C++ for almost 3 years now and I still don't know many of its features, alright? So it's practically impossible for me to tell you everything about C++ in this series. But don't worry, I'll tell you all the basics and everything that you need to know to kickstart your C++ journey. Okay, so let's get started. What I plan for this tutorial is I'll show you two sample programs, alright, so that you actually get to know what C++ can do. After you have an idea of what all you can do and what C++ is actually capable of, I'll tell you where to get the required software from. Don't worry, it is absolutely free. Alright, let's go ahead then. So here's the first program which I wanted to show you people. Now this is basically the easiest program which one can make on C++. So let's go ahead and see what it does. It simply prints hello on the screen. Alright, and here's the next one. Now this program is basically a school project which I made during my 12th class. Alright, so as you can see, this is a pretty long piece of code. Alright, but don't worry, it's very easy. And guess what guys, you will be making this code in the end of this tutorial. Alright, I'll tell you how to make the snakes and ladders game, which is basically this code, in the last few tutorials. So let's go ahead and see what this code actually does. That's Saregamapa, as you might have guessed. So look here guys, all these awesome graphics, all the snakes, ladders, all the text with different fonts, the background color, everything is made exclusively in C++. Alright, this is the instruction screen. Alright, spacebar to roll the die. Here we go. The die shows 1. There we get a pointer on 1. Good. The die shows 1. 1 plus 1 is 2. So we'll get the pointer on 2. Let's take one more step. The die shows 3. So we get it on 5. Exactly. So that's basically what this code does. Alright. So as you can see, just from printing a simple text on the screen to actually making a game, you can do anything you want on C++. Alright. Now let me tell you where to get the software from. Alright, just go to this link right here. When you'll click on this link, the download will start automatically. Alright, so once you have downloaded the setup, I have mine right here. Let me just guide you through the installation process. Now what I want you to do is I want you to pay a close look at all the various files which this process will show us. Alright, I want to tell you something interesting. Okay, obviously English, I agree. Next. Just one thing, I just remember this path. Alright, C program files div C plus pp. Alright, and one as I said, just pay attention to these files right here. Right, so as you can see, pacman.exe, there are a few programs which come pre-installed in div C++. Alright, so there are few codes, like I made snakes and ladders, so you get pacman and a few more, some rainbow app and all, so that you actually can see what you can make with C++. Alright, just like the two sample programs which I showed you earlier, except I made them myself. Okay, so by the time the setup is running, I want to mention someone right now. Alright, so just for your knowledge, whichever operating system you are using currently, be it Windows, be it Mac, be it Ubuntu, Android, Red Hat, anything, it has C++ somewhere inside it. Alright, because all the modern languages with which these operating systems are now written on have basically been inherited from C++. Okay, so there is a bit of C++ still used in these operating systems, and this man right here is the one who actually wrote C++. Alright, he is behind everything related to C++. The name's Bajan Stroutstrup. Alright, that's the name. Let's go ahead with our setup. Alright, so now as you can see, there are many .h extension files here, like you can see limits.h, and you will see a few more after a while. Alright, so what the .h basically stands for is, h means header. Alright, they are header files. And now there are certain functions which are already defined for us to use them directly. Alright, for example, if you want to print something on the screen or take an input or something like that, or even power exponentiation or square root and all that, you don't have to actually write programs for that, because C++ provides us with certain functions which we can use as it is. So these functions are stored in these .h extension files. Alright, so the input output functions are in a file called iostream. The mathematical functions are stored in a file called math.h and all that. So we need to include these header files whenever we want to use those functions. Alright, and one more thing, guys, uh, during these tutorials, if I tell you to do something, like I want you to try out a few codes before, before going to the next tutorial or something, make sure you do that, okay? Because I am very sure you won't understand everything unless you do whatever I tell you to. Alright, if I say ki try a few programs out, I'll give you the programs, don't worry. So if I say ki I'll try out a few programs before watching the next tutorial, please do so. Alright, so that if you go by my, if you follow me properly, I promise you will get to learn a lot in this tutorial series. Alright, finally the setup is completed. Just hit run dev C++ and click finish. So as you can see, we get a hello world sample program right here. Don't worry, we'll make our very own in the next tutorial. English, of course. Next, you can change the font if you wish. I prefer consolas. I prefer the classic look, the new icons. Just hit next. You can customize it any way you want. In this page, guys, just make sure you only click this recommended button. Alright, because if you hit click the first one, it will take a lot of time and we don't actually need all that. Okay, so just hit the recommended button and click next. Okay, so here's what Dev C++ actually looks like. Welcome back to the second tutorial, guys. Now I hope you have downloaded and installed Dev C++ as I told you in the previous one. So let me give you a tour of the interface. Alright, so file, in the file option you can find all the normal basic file operations like opening a new one or saving files and all. We don't actually need to use any of these except execute. Alright, just remember execute, because when we want to run our code we need to do it from execute, or you can use the shortcut key F11. The tools, if you want to customize Dev C++ according to your need, you can do that with the tools thing, but I don't think you need to worry about that right now. If you want any uh, tip of the day or something like that, you can go ahead and hit those buttons. You can mess around with the interface, guys. It's nothing, it's very basic. So this here is the compiler which this one uses, the GCC compiler. Alright, I'll tell you what compiler is in a while. So let's go ahead and make a very first hello world program as I promised. So the first thing which we need to write is hash include iostream. Alright, now what the hash stands for here is, the hash basically means preprocessor. Alright, so whatever statements follow hash are processed before the code is actually compiled. Alright, so include basically means include the header file whose name is iostream with our program. Alright, now make note of this, guys. We don't actually need to write the .h extension for certain header files like iostream. Alright, you can write, or if you don't want to, you should not. Alright, does not matter. The next thing is using namespace std. Okay, so what namespace stands for is the area on the disk where all the contents related to this program will be stored. Right, I'll tell you in a while that how actually the .cpp file which you are going to make is converted into an executable file. Right, so all those files which are temporarily created are stored in the area whose name is std. Now you can give any name here you want. Namespace is the reference of the folder and std is the name of that folder. All right, the next thing and the most important thing is the main function. So whenever we run the program, the control first passes to the main function. All right, so now one more thing guys, as you can see, if I insert a left bracket, the Dev C++ editor puts the right bracket for me. All right, so I don't need to worry about that. Now this is helpful in many cases, but sometimes it might cause problems, so just make sure you have a proper look at all those brackets. Alright, because while debugging the code, one bracket may spoil the entire thing. Okay, so yeah, so what main basically does is whenever we run our code, the control first comes to the main. We can pass the control anywhere we want from within the main function, not from anywhere else. Alright, so if your program does not contain a main function, it will not run. Okay, so now we want to print hello world on the screen, right? Hello world. Just make sure you do a couple of spelling mistakes here and there, keeps it interesting. Okay, so this string, probably I should correct this one. Okay, so what cout basically is, cout is an object. Alright, it is predefined in this file which stands for input output stream. So what this statement basically does is it prints whatever content we give here within these double quotes on the screen. So this content is passed to cout, which then again passes it to the screen or its stream. It's like a flow of bytes. Okay, and every statement in C++ ends with a semicolon. Alright, now since main is a function, it won't end with a semicolon. I'll tell you what a function is after a few tutorials. So for now, just remember that every statement ends with a semicolon. Okay, so let's go ahead and save it and see if it actually runs. Hello, go ahead, execute, hit compile and run, and there we go. Hello world. Cool. So now if I want this to, I want my code to run on my friend's laptop as well, but the problem is he does not seem to have Dev C++. So is it possible that whatever code that I just wrote runs on all the other laptops out there who don't have Dev C++? Absolutely possible. All right, so what if I tell you that whatever code you have written just now has already been converted into a .exe file? Yes, remember .exe, all the setups, everything which we install softwares from are .exe files. So what if I tell you that your code has already been converted into a .exe file? Don't believe me? Well, just go to your documents folder. All right, because the default location is of Dev C++ is documents. You can change the location from the file and save as option, and you can save whenever you want, but right now it's stored in documents. Okay, so there, yes, hello, this is what we made right now, isn't it? But wait, what is this thing right here? We didn't make any of it. This is the .cpp file which we made. Let's go ahead and see the properties. There we go, it tells a .exe extension. Okay, so let's go ahead and see what it does. Oops, if you see properly, it's still displaying the text, but it's not waiting for anything. Now obviously it will not wait for anything because we haven't written the code for that. We have just written a code to print hello world or hecko world, but we haven't wrote anything to make it stall for a few time. All right, so now what we are going to do is we'll just add one function which is called getch. Now getch stands for get character. So what this will do is it will basically stall the code until the user enters any character through the keyboard. Okay, so for using getch you need conio.h. Alright, conio.h. Now you need to specify .h for conio. Alright, so let's save it. Okay, it's saved. Let's go back to documents and see. Oops, still not working. Of course. Now get this thing clear, guys. The .exe file will not be modified unless you compile and run your program in dev C++. Okay, so we just saved it right now. We did not actually compile it, so the .exe file has not been modified just yet. If we go ahead, we hit compile and run. There we go, Hello World. All right, so it will wait for a key this time. Let's go ahead and check it. I run this again. So there we go, our code is now waiting for a response from the user. So as soon as I press any key, the code is exits. All right, now you guys might be wondering how the code is actually converted from .cpp to .exe, right? So basically it's a four-step procedure, right? In the first step, what happens is all the comments and all are stripped off. Now what comments are is you will learn in a few tutorials. uh, the hash statements are executed first in the first step. Then after that, the code is checked for any errors. If there are any errors, it will show you and stop the process right there. The third step is converting this into a machine language code. Now obviously the computer is not going to understand English, right? So we need to convert it to a machine language code. Now once the code is converted into a machine language code, it is the extension for that is .o. It is called object code. Okay, what we write in .cpp file is called the source code. So source code is basically first converted into the object code. After the object code is made, all these files are linked together: the iostream file, the conio file, and our hello.cpp file. All these are linked together, and finally one .exe, that is executable file, is formed. That's the basic process how .cpp is converted to .exe. Alright guys, so that's it for this tutorial. Make sure you practice this code and display your name or something like that, and then I'll see you guys in the next one. Welcome back to the third tutorial, guys. So this is where we stopped in the previous one, right? So let's go ahead and make a new file. In this tutorial, what we are going to do is we'll make a simple basic calculator application. Okay, so we'll take two inputs, two numbers from the user, we'll add them, we'll subtract them, and maybe multiply, divide, and all. Okay, so let's get the basic syntax in place. iostream using namespace std main. Okay, so now to define the two numbers which we'll be using, we use int a comma b. Okay, so what int represents is a data type. Okay, there are 5 basic data types in C++. One is int, then there's float, double, char, and void, right? So these are the basic predefined data types. There are few others which I'll tell you in due course. So int is integer, float is floating point. Now what floating point actually means is decimal values. Double is double precision, which is for numbers having the having 10 to the power something. It might be the size of the galaxy or size of an atom. Those numbers, the big, the very huge and very small numbers. Okay, character stands for char stands for characters, and void stands for, basically void stands for nothing actually. So if you do not want your code to do anything, you use void. We'll use it in certain functions, not we cannot declare variables of this type. Okay, I'll tell you what functions are in the upcoming tutorials. Okay, so for now, these are the 5 basic data types, and in this one we'll be using integer. Okay, now again we'll ask the user for their values. So enter two numbers, good enough. C in a and B. Okay, so I told you what C out does, right? So C in is basically the opposite of C out. Whatever value the user enters through the keyboard is taken from the screen and it's stored in A. Alright, similarly it's stored in B. Now instead of this we can also write it like this, C in A, C in B, but that basically does not look good. Okay, why to waste another line when we can do it in a single line? So when we do it in a single line, this particular syntax, it is called concatenation. Just a theoretical word, has nothing to do with the code. Okay, so now we have our two numbers. We'll display the sum. Now just to make the output a bit more appropriate, I'll be using endl. What endl stands for is end of line. Okay, so it what it basically does is it moves the cursor to the next line. Okay, and L, and we'll say the sum is, and again A plus B, just like that. Okay, so that's a basic sum displaying program. Let's see if it actually runs. It will first ask us to save. I'll just save it as calculator. Maybe you save it whatever you want. Let's go ahead and run it. Okay, enter two numbers 3 and 6 and the sum is 9. Cool. But you get to choose what you want in a calculator, right? You can choose if you want to add or you want to subtract or something. Okay, so let's go ahead and try to make that. Okay, now before taking two numbers, what I am going to ask the user is I'll tell them to enter your choice. All right, so we'll just display a few things in the choice, and L1 for add slash n. Now slash n is another alternative to endl. All right, does the same thing. And 2 is subtract. You can go ahead and type multiply and divide if you wish. So I'll need to read the choice, then depending on the choice we'll choose what to do. So choice, now I need another variable here called choice, right? Because we need to store the one or two whichever the user enters in a in choice. Okay, so now we'll need two numbers. Okay, so let that code be as it is. Now let's go ahead and choose what we want to do. Okay, so for choosing something, what we need is, what we basically say is, if the user enters 1, add them. If the user enters 2, subtract them, else don't do anything. All right, so that's what we do in C++. All right, if choice is 1, display this, else if choice is 2, see out the difference. Difference is A minus B. Alright, else if choice is neither of the two, we'll just say maybe invalid choice or something. Okay, so this is basically called if else ladder. Okay, if you can have multiple conditions, if else if choice is 2, else if choice is 3, multiply, else if choice is 4, divide, else if it is nothing of that, just print something key you have not entered the correct choice. Okay, so let me quickly tell you a bit about if else. Okay, so if again the syntax is if the condition in the brackets and the statement following it. Okay, so if you want multiple statements here, if you want to see out the sum as well as something else, so what you can do is you can go ahead and cover all of them in a block, right? So this opening and this closing, because just remember one thing, if you do not have these blocks, only the statement following the if will be a part of that if statement. All right, so if I don't enter these blocks here and I uh, print something else here, it will probably not be executed because it is not a part of that if. All right, unless I put them all in these brackets. Okay. Yeah, one more thing. What if I want to do multiple things if choice is one? I can have another statement here, like if choice two or something is four, then do something else. So what I'm basically mean here is that you can have if else inside else also. You can have men wherever you want. Alright, just make sure you have one if and one else for it. Okay, so if you want to have else, you need to have if. Okay, you can have if alone, but if you want else, you will need to have an if before that. Okay, now before ending this tutorial, I'll tell you a bit about the comments. All right, so what comments are basically is just for writing some stuff in your code, so that when I check out the code, I don't forget what a particular line actually does. So I'll just comments are made using double slash or slash star and again star slash combo. All right, so double slash is for the single line comments and the star slash one is if you want to cover multiple lines. I can just write to add, then I can go down here and I can write to subtract, and also that when if at a later point of time I need to come back and check what particular part of the code actually does, I don't need to worry about it because I have already made a note for myself. Okay, and now you might be thinking that these comments are useless because I don't need to remember how to add. If I it's a single line, I can anywhere anytime guess it, right? But let me tell you one cool little trick. Okay, you do not necessarily need to add comments only for reminding yourself, though it is preferable if you do that, but it's not compulsory. So the another way of using comments is using debug for debugging. Okay, so if a particular part of your program is not functioning properly and the other part is functioning, so what you can do is you can just go ahead and you can just skip this part of the code and check if this one is working properly. You get it? So that I know this is working fine, but there's some problem with this one, so it reduces the amount of code which I need to focus on. All right, so that's how comments can alternatively be used, and mostly people use comments only for this. No one uses them for writing and making notes or something. Okay, so that's about it for this tutorial, guys. In the next one, I'll tell you about the switch case. We'll make the same program again using a switch case, because for programs like this which have many choices, the if else is not the best way of doing it. Okay, if else is for those cases where conditions are less. Okay, but suppose if I have in actual calculator, if you see, there are maybe 15-16 operations including sine, cos, tan and all. So I am not going to write if else if. Alright, there's another much cleaner, much simpler way to do it, which I'll tell you guys in the next one. Just make sure you try out if else. I have included a few sample programs in the document attached. Make sure you do all of them. I haven't given the answers to them yet. I'll give you that in the next one. So go ahead, try all of them out, mess around a little bit, and I'll see you guys in the next one. Hello guys, welcome back to your fourth one? Right, fourth tutorial. Okay, so as I said, in this tutorial we'll be making the same calculator program, but it will be much more appropriate, much more simpler and much more beautiful, right? My sir always used to say, even if your program does not run properly, it does not get the required result, just make sure the output is beautiful. So in the end of this tutorial, I'll tell you a few tips to make your output a bit more user friendly, you can say, a bit more beautiful to eyes. Okay, so let's get started. In this one, let's use float for our variables. Alright, float, as I told you, float is for decimal values. So we'll do the same thing. uh, just let me go ahead and copy this code. We'll ask for the choice and the two numbers. Alright, so let's make our choices a bit more. 3 is for multiply, of 4 for division. Okay, let's go ahead with 4. Okay, so what we'll be using for this one is we'll be using a switch case. Alright, so switch, uh, that is the basic syntax. Switch the variable which is one with multiple choices and these braces. Alright, so the variable which we pass to switch function is the one which is going to change its value. Alright, so if the user enters 1, the choice is 1, if 2, the choice is 2. So you get what I mean, the one which will actually decide what the code is going to do. Alright, that is what we pass here. Okay, so in switch we use multiple cases. Alright, so case 1, what this basically means is if the value of choice is 1, then do this: out the sum is, the sum is a plus b. If the case is 2, that means if the value of choice is 2, out the difference is a minus b. Case 3, the product is a star b. And you can go ahead and add the last one for the division: a by b, a slash b. Alright, just do that. So okay, let's see what the code does. Let's go ahead, save it, switch, execute, compile and run. Oops, we forgot to include declare choice. Let's do that. Int choice. Don't worry about the errors, guys. The more errors you solve, the better you get. Okay, so there we go. Add, subtract, multiply, divide. Since we haven't written it yet for division, let me go ahead and select subtract. Enter two numbers, 5 and 2 maybe. So the result should be 3. The difference is 3. The product is 10. Whoa, whoa, whoa. What is wrong? Why did it show the product as well? Well, there is something about switch which I haven't yet told you guys. Alright, it is basically that whichever condition is satisfied, everything following that condition is executed. Alright, so in this case, since it was 2, so 2 along with 3 was executed. Okay, so if we want to just I just want 2 to be executed or only 1, we use a keyword here called break. Now what keywords are basically some predefined words which have a special meaning for the compiler. Okay, just like when we say ki I am hungry, so hungry means I need food. Similarly, for the compiler, break means it will exit the innermost thing which it is in. Okay, so the break here will exit from the switch statement and return the control back to the statement following it. Okay, so similarly for these two cases. Now there's one more thing: if neither of it is satisfied, so we get to set a default case, just like in the previous one we did with the else one, invalid choice. Same thing we can do with the default case. So what it means is if neither of these conditions satisfy, you can use the default one. Okay, and one more thing, it is not necessary for us to go in a particular order. I can use 3 first, then 1 in between, 2 after that, 10, 20, whatever case I want depending on my situation. They don't need to be in any particular order, or it does not matter. You can use 1, 2, 3. You can even use characters A, B, C and all that. Okay, so in the document attached there is a lot about switch case, so just make sure you read everything properly so that you can utilize it for making your program even more better. Okay, so let's go ahead and check it once again. This time I'll calculate the sum. Okay, 1, enter two numbers, 3 and 17 maybe. The sum is 20. There we go. Everything is perfect. To be honest, not everything is perfect. I don't like the way it was displayed. Okay. Let's see it once again. So as I said already, I prefer the output to be more beautiful. Alright, so what we can do here is, since we see a space here, we can just go ahead and remove this space. Again, what is happening is the pointer is right here, after the division. It's not going to the next line. So let's go ahead and put a slash n, so that the pointer goes to the next line, so that it does not look strange that I am entering the choice right here. Okay, just like we have slash n, or rather backslash n, we have many more things like backslash t, backslash a, and a whole bunch of them. Okay, they are in the document attached, you can go through them. So what these backslash actually has a special significance. Okay, so whatever follows backslash, a few of them have a special meaning for the compiler, just like the keywords do. So slash n stands for new line. We have a slash t for horizontal tab, which is basically put some spaces before, whenever you type in a word document, you hit tab, it inserts some space. That is exactly what slash t does. Okay, in spite of all that, there we go. So you see now our cursor is here, so we don't it does not look strange. Okay, so I want to add, enter two numbers, 3 and 4. The sum is 7. Perfect. Alright guys, so what we have learned in this tutorial is about the switch case and about the slash n and slash t escape sequences. Okay, that's what they're called. They're called anything followed by a backslash and a special and a character which has a certain special meaning to the compiler is called an escape sequence. Okay, so we have learned about two escape sequences in this one, the slash n and the slash t. I'll tell you more whenever we encounter them. Okay, so that's it for this tutorial. Make sure you practice all the programs attached with the file with this one, and thank you for watching. I'll see you guys in the next one. Welcome back to your fifth C++ tutorial, guys. Now in this tutorial we'll be talking about loops. They are also referred to as iteration statements. So if we go by a literal meaning of loop, it means continuous. It means something repeating many times, right? So similarly, if I want to display numbers like 1 to 100 or characters from A to Z, I won't sit all day typing C out 1, C out 2, C out 3, C out 4. There has to be a way to do this job in a single not single, maybe in 2 3 lines, right? So that's where loops come in. So there are three types of loops in C++: for loop, while loop, and the do while loop. In this tutorial we'll be talking about for and while, and I'll tell you about do while in the next one. Okay, so there are three things associated with a loop. All right, so just like anything else, for has opening and closing brackets and these braces. All right, so in here we need to give three things. First thing is the initial value. All right, so what we mostly do is we define a variable here. Let's do a code to print characters from A to Z. All right, so the variable is C equal to A, will start from A and will go to Z. C is less than or equal to Z C plus plus. Alright, so what this basically means is we have set a character C whose initial value is A, and it will continue to run the loop until it reaches the value Z. Alright, and in every step the value of C will be incremented by 1. So if in the first step C is A, next it will be B, C, D. all the characters are also represented in the memory in the form of integers only. So if I say c plus 1, it's valid in case of characters also, because c plus 1 basically refers to adding 1 to the ASCII value of c. ASCII value is the integer version of the character which is stored in the memory. All right, so let's go ahead and see out the value of c, so we get to actually see if it works or not. Just save it. Characters, maybe, spelling mistakes, I love them, and compile and run. There we go, A to Z, right? So that's what basically loops are for. You can, it saves you the task of writing 26 different cout statements. You can just do it with 2 steps, right? So let me just revise it once again. The first thing is initialization, the second thing is condition, and the third thing is increment or decrement or updation, right? So let me tell you the flow of the program. C is first initialized to A, right? Then it is checked if it is less than Z. Of course, A is less than Z if we go by the ASCII values, and if we go by the character set also, A comes before Z. That's it. So then it will go to the loop, it will print the value of C. Once the all the statements here inside these braces are completed, it will go back to updation. Alright, so then C++ will set the value of C to B. Then it will again check if it is less than Z. Yes, it is, so it will again run the loop. Next, again the value of C will be incremented by 1, and this process will go on until it reaches the value of Z. Once it reaches the value of Z, the condition fails, and then the loop is over, right? So that's what for loop is. Now let's go ahead and do the same thing with while loop, right? So there's a basic syntax difference between for and while loop, rest everything is the same, right? So we'll say while c is less than or equal to z. In case of while loop, what we need to do is we need to declare or initialize the variable outside the loop before the loop, right? So we'll just say c is equal to a outside the loop, then in condition is right here, and the updation statement comes within the loop, right? C out c and c plus plus. So let's go ahead and run this code again, so that we get to understand if the output is the same or not. There we go, we get the exact same output. So what the basic difference is: initialization before the loop, outside it the condition, and updation inside the body of the loop, right? So that's the basic difference between for and while. Most of the times they can be used interchangeably, but in certain cases, if you do not know the initial value or something, you do not know how many times you need the loop to run, in certain cases, in such particular cases, we use while. Using while is far more challenging than using for, right? So mostly we go for. I personally prefer for loop. I try to use for wherever I can, because playing with while is a bit dangerous, right? So that's about these loops. Let me show you a few simple examples to display some shapes, right? For I is equal to 0, I is less than 17, maybe I plus plus. uh, just make it integer here, right? So we can see out asterisk maybe, and that's it. Let's go ahead and see what happens. It will just see out 17 asterisks in 17, no, not different lines, same lines, right? So that's what this code does. So what if I want the asterisks to form a certain shape? I want one asterisk on the first line, two on the next, three on the after that, four after that, and like that. So for that we need to add another loop inside the for loop, another for loop inside the for loop. Now of course for another loop we need another variable. For j is equal to I, j equal to 0, j is less than I, j plus plus, and see out this, go out of the j loop, no, end the j loop right here. Just make sure you indent these things, right? Indentation basically means putting some gap between the various loops, right? So you get an easy understanding. So this first for loop ends here and this inner loop ends here, right? It's easier to look at the code this way, plus it's more beautiful. All right, so now if I want my asterisk to be on the next line, I'll need to add end l here, and l, that's it. Let's go ahead and see what it does. Compile and run. There we go, beautiful, isn't it? So let me just tell you what this code actually does, right? So when the value of I is 0, j is also 0, so nothing happens. So that's why the first line was blank, right? When I is 1, j starts from 0 and 0 is less than 1, so it only runs once. When I is let's say 10, j starts from 0 and runs till 9, right? So 9 asterisks will be displayed. Alright, so for each and every value of I, j runs more than one times. Right, this is called, again this is called nesting of loops. One loop inside the another one is called nesting of loops. You can even nest while loops inside each other, but that is highly unadvisable, right? So that's basically it for this tutorial, guys. Go ahead, try a few shapes. Again, I have included various shapes in the document, so just go ahead, try them out, and then I'll see you guys in the next one. Welcome to your 6th C++ tutorial, guys. So as promised, in this tutorial I'll be telling you about the do while loop. Now the for and while loop mostly satisfy all our needs, but there is one particular condition where both of them fail, and that is where the do while comes in. The do while loop can be used everywhere, but it is specifically mostly widely used only for one particular situation. Alright, so let us assume we go to a restaurant. Alright, so the first thing which we do is we look at the menu, right? So it might be possible that we do not want to order anything, or if we don't like anything from that menu, we will not order anything, but nonetheless we wish to see the menu at least once, right? But when we try to make a code for this particular thing using for or while loop, it is not possible because we'll make the loop for taking orders, right? So if you do not give an order, the menu will not be shown to you. The menu will be shown only if you choose something, right? So the do while loop, what it does is, it, even if the condition fails for the very first time, it still executes the code in its body at least once, right? Let me just go ahead and show you. Int I do, followed by these braces, and then while, and the condition here, right? So as you can see, there is a basic difference between the syntax. Do followed by the loop, followed by the loop body, followed by while, and then the condition. So in the for and while cases, the condition is checked before entering into the loop, but in this case the condition is checked during the exit time. So even if the condition fails for the first time, the body is executed at least once, right? So let's go ahead and make a program for that menu which I was talking about, right? Again, I'll ask him for a choice, one, eat, two, maybe parcel or something, right? So I need a variable for that, choice, right? So in choice, inside the do, let's display the menu or something, right? So hello, welcome to our restaurant or something, right? So we need to ask for the choice after they have entered the restaurant, right? So just go ahead, cut this thing, and put it right here, while choice is greater than 0, just for the timing, right? So let's go ahead, let's save it and see what it does. Do while maybe. Okay, compile and run. Before see out, I missed something. All right, there we go, that's what I missed. Execute, compile and run. Hello, welcome to our restaurant, and then it will ask for choice, right? So we can enter the choice and you can write the, I am sure you can write the code for the various choices, right guys? So that's what do while is for. uh, what I want you guys to do now is just go ahead and try out the same exact code using a for or a while loop, right? You will get to know what I actually mean. Okay, you will get the difference very clearly if you try it out yourself. Hello guys, welcome back to your 7th C++ tutorial. So in this tutorial we'll be talking about functions, right? So suppose it's your birthday today and you are having a party at your place, right? So what we normally tend to do is you will order cake from some place, you will order dinner from somewhere else, and you will probably order the decorations from somewhere else, right? So what I am saying is we'll divide the work into individual parts, right? You will appoint different people for different tasks. So since C++ is the application of exact real world things into programming, that's what exactly we can do with C++ too. We can define various functions to perform various tasks, right? So one particular function performs a specific task. So that's what we are going to do in this tutorial, right? So it's your birthday, right? So let's go ahead and make two functions. Probably one will be about the invitation list and the second be about the menu of the party, right? So now you can define functions inside the main as well as outside the main. The best practice is to define them outside because as I've said many times before, keep the code of main as simple as possible, right? So let's go ahead and define a function for invite list. Okay, that's basically the syntax, right? Exactly like main. Instead just we have void here because right now our function will not return anything back to the main function. What this means is that whatever code will be within this function, it will be self-sufficient, right? It does not need to return any value or take any value from main. Alright, so this is the name of the function and this is basically the argument list. Right now we don't need any arguments. So what this function is going to do is it will basically display the name of people who are coming, right? So maybe friend1 slash t, maybe 2 dot friend2, and you can go on with the list, right? Alright, so this is one function. The another function is about the menu, right? So let's go ahead and take a choice, suppose vegetarian and non-vegetarian. So I'll need integer for that, right? Integer choice. Let's go ahead and define the function. If choice is 1, again see out here, oops, here's the list, and 1 dot 2 dot 3 dot the various items whichever you want, right? Then again, if else if choice is 2, uh, you can go ahead and display the names of non-veg items or something, right? I don't know what TNR means, right? That's basically it. So now we have defined the functions, all right, but we have to call it in the main function to use it, right? There are three things associated with a function, right? The first thing is the function definition, which we have already taken care of. The other thing is function prototype. Now if we define the function before main, we do not need to put the prototype, but if the function is defined after main, which is defined after main in our case, we need to tell the compiler that we there is a function with a name of invite list and menu somewhere in the program after the main program, right? we are just telling it that, hey, there's a function called invite list, don't forget to add that, right? So now we'll just simply call invite list just like that, and menu, right? So this is a function call, this is a function prototype, and this is the function definition, right? But there's one thing, we can call invite list just like this because we do not have any arguments. But for calling the menu function, we'll need to provide the argument, right? So let's go ahead and take care of that. Do you want veg or non-veg? Right, see in choice. Again, since we are using choice, we'll need to define choice here. Choice, there we go. So now we'll write choice here. So what this line basically does is it will call the menu function with the value of choice as whatever the value of choice is here, right? So these are called the actual arguments, and these are called the formal arguments, right? So when we define it in a function, it is called a formal argument. When we call it, it's called actual argument, because what we are doing is we are copying the value of choice which is entered by the user to the value of choice which we have declared in the function, right? So if the user enters 1, this it will print probably here's the veg list, and then if user enters 2, then it's the non-veg time, right? If it if the user enters something else, well, you know how to handle that, right? So let's go ahead, save it and run it and see if it works. This is functions, right? There we go. Execute, compile and run. There it is. So it's displaying the list first. This is what /t does, right? It gives a tab between the two words, right? So do you want veg or non-veg? Well, of course, if there's non-veg, I want non-veg, right? So there we go, non-veg TNA, whatever. So that's basically what we have done. So you don't actually need to make separate functions for operations as simple as that. But again, when we'll make snakes and ladders, you'll get to know about why do we actually need functions, right? Because there, what I basically did was I made functions for every screen. The first screen was a separate function, the instruction screen was in a separate function. So in the main body, I just have to call the screens one after the another, you know. So that's how it simplifies my code, right? So that's about it for the function concept, guys. Again, I've included a few programs for you to try out. The code will be provided in the next tutorial. Try them out. Be thorough with functions, they are a very important part of C++. Now again, you can use comments to check a particular function is working properly or not, just like that. Just go ahead and comment this one, so that everything related to invite list is now commented. So your code now actually contains only the menu function, so you can go ahead and check out menu function. If it has any errors, you get it, right? So that's it then. Go ahead, try the programs out, and I'll see you guys in the next one. Hello guys, welcome back to your 8th C++ tutorial. Now in the previous tutorials we have almost covered all the basics. There's just one more concept left, and that is array. Array is basically a collection of similar data elements, right? So suppose there are 50 students in a class and I want to store the values of all the 50 students. So I'll not sit all day and write a1 a2 a3 till a50, right? There has to be a way to make 50 reserve 50 places in a single statement, right? So that's where array comes in. What we can do is we can just go ahead, we can write mark or whatever name you want to give it, and we can just specify 50. So what this statement basically means is reserve 50 integers who will be referenced by the name mark, right? So what happens is the reference or the index, this is called the index or the subscript, right? So it starts from 0 and it goes until 49. Alright, just one less than what we define, right? So if we say 50, it is actually from 0 to 49 in the memory. Just remember this, the total size minus 1. right? We'll need it in the loops. Okay, so that's what an array is. It's a collection of similar data elements. You cannot have 25 characters and 25 integers in a single array. That is not possible. That is the drawback of an array, right? Another drawback is, if you need to insert an element somewhere in between, you need to shift the entire array here and there. Okay, we'll get to that. So now let's go ahead and read the 50 marks, right? So I'll ask the user to enter, maybe enter the marks, right? But it would be really hectic if I have to sit and enter so many marks right now. So what I'm going to do is, I'll first ask the user to tell me how many students are there, right? How many students are there, because it's not necessary that every class has 50 students. Let us suppose the maximum one can have is 50, right? So in my class there are only suppose 30 students, so I'll skip the 20 places, right? That is the only problem. I cannot have 30, or I cannot define this at a runtime. I have to declare it initially. That's another drawback of array. So I'll take n, maybe, so I'll define another integer called n and I, which I'll need for the loop, right? So again, when I say enter the marks, I'll not write 50 different cout statements, right? So that's basically it's about repeating a particular set of statements many times. So that's where loops come in, right? So I'll just go ahead and I'll see in a mark of I, right? So just I want to emphasize on this thing here, guys. In case of array, it is preferable to start from 0 and go to size -1, right? Because I less than n is basically I less than size -1. So if n is, I suppose n is 5, right? So the loop will run from 0, 1, 2, 3 and 4, and that's exactly what we want. Suppose we started from 1 and we take it till less than equal to n. It will be valid in other cases, but here we need to store it in 0, right? So if we enter 1 here, the first value will be stored in 1, and the 0 value, mark of 0, will store garbage value, right? So that's not what we want to make to happen, right? So that's basically the best way to use loops with arrays. Better we start it from 0 and take it to n. Okay, so that this piece of code will take whatever, however number of values the user wants, right? So let's go ahead and write how to display them again. So here's what you entered, right? So again we need to, I'll not write cout 50 times, right? So we'll need another loop here, same conditions. Instead of cin, I'll just write cout mark of I and end l, maybe, to make it a more clear, right? So that's about it. Let's go ahead and save it and try to run it. All right, how many students? 5 students. Enter the marks: 3, 4, 3, 4, 5. Here's what you entered: 3, 4, 3, 4, 5. See, perfect. So that's the basic thing about arrays. Let me tell you once again. Array is a collection of homogeneous data types. This statement tells the compiler to reserve 50 integer values which will be referenced by mark. It starts from mark of 0 to mark of 49, right? Now let's inculcate a bit of the function concept here. Suppose if I want to search a particular value in my array, right? So for that I'll need an array, obviously, array, and the value which is to be searched, right? So that's the basic syntax of the function in place. Now what you can do is, you can just go ahead, copy it, and you can paste it here as it is, or just remove the name. You can leave the name here as it is, but that's not recommended, right? So just remove these names. All right, so that's the prototype of the function. Here the definition will come. The other thing is left is the function call, right? So before actually calling the function, I need to ask the user about which value do you want, right? Which value is to be searched, right? So that I'll store in, so let's say key, right? So I need a key here, key, there we go. Okay, which values to be searched? Now we don't actually need to display all these values, so let's go ahead and comment it off. Right, so which values to be entered that the user will give us. Then we'll call the function search, we'll pass the array and the value, right? So again, while passing an array to a function, you don't actually need to include these brackets, right? That's not necessary. We are left with the definition, of course. Another little tip, guys, whichever name I give here, alright, and the name of the array here need not be similar, alright. So what this statement basically is going to do is it will copy the values of mark into the value of array and the value of key to the value of key. I can give it any name I want, right? Again, I'll need two more variables here, I n, because the variables which are declared inside a particular function are valid only for those functions, right? So there are two ways to solve this problem. Either I can go ahead and I can define the variables right here, so they can be used anywhere. Now whenever we define variables outside the main, they are called global variables, which I am not going to do in this case, and the variables which are defined inside a particular function are called local variables, right? So as the name suggests, local variables are valid only within that function and global variables can be accessed by all the functions. So since this is another function, I cannot access the variables of the main function with this one. Alright, so we'll need to search the value. So let's again go ahead and write a loop, because we'll have to scan through the entire array, right? I plus plus. So if the array location matches with my key, right, I need to tell them the element is found, else that element doesn't seem to exist, right? You write whatever you want, I wrote whatever I want, right? So what this will do is this will start the loop, then it will from the first position it will go on checking until the last one. If the value of key is matched somewhere, it will say the element is found, else it will print that element does not seem to exist, right? There will be one problem with this thing, but let's go ahead and check the problem. If it will be better if you see the problem first before I tell you the solution, right? Alright, I want 5 again, 6, 7, 8, 9 and 5 maybe. Here's what you entered. Oh, I forgot to comment that one. No problem. Which value is to be entered? I'll need 9. That element does not seem to exist. So as I said, there's a problem with this one, right? Because I entered 9 there, so it has to be there somewhere. Alright. So as I said, there will be a problem, right? Here's what the problem is. We have not given the value of n to the function, right? So it is taking some garbage value. The loop will not run any, the loop will simply not run because it does not know that user entered 5, right? Because whatever we have taken, the value of n is stored in the main function, it's not stored in this search function right here. So either we can define it global or we can again pass another argument here, right? So instead of passing another argument, let's go ahead and make it global, right? So I and n, right? So now I'll need to remove this thing because it will say multiple declaration, right? Int key, int mark. All right, seems good. So is it all right? Let's go ahead and see. I don't think so. There will be just one more problem, right? 6, 7, 8, 9, 5. Maybe I want 6. Whoa, 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 whoa. The element is found but does not exist, does not exist, does not exist, does not exist. What is this? Okay, it's found, right? Means the code is correct. So I'll tell you what the problem is. For each value of the key, whenever the key is not found, it will go ahead and it will print that element does not seem to exist because the cout statement is inside the loop, right? So what we are actually doing here is that if the value is found, print element is found, else if the value is not found, print that element does not seem to exist. So in the very first location the value was found, so there it printed element is found, but in the remaining places this thing will be printed, right? So there are two solutions to this particular problem. What we can do is either we can go ahead, we can make a block and use the break statement which I told you about. So once the element is found, the loop will break, right? Or the other solution is we can use a temporary variable int temp, right? So we don't need break in this case. So what we can do is we can modify the value of temp here. Temp is equal to 1, right? Else make it something like temp is equal to 2, right? So again, after the loop what we can do is if the value of temp is 1, make sure you use double equal to, right? Because single equal to is initialization, double equal to is comparison, right? So if I write if temp is equal to 1, so this is valid always, right? Because we are storing the value of temp as 1 in this case, but in this case we are checking if temp is 1 or not, right? So what we can do is if temp is equal to 1, then go ahead and see out the element is found, right? And else or else if temp is equal to 2, uh, just go ahead and print out that element does not seem to exist, right? There we go. Let's go ahead and check it once again. Temp, so it will keep on searching. If the element is found, it will change the value of temp to 1, else the value of temp will be changed to 2. So if the value of temp is changed to 1, it means the element has been found. If the value of temp is 2, it means the element does not have been found. Else we can just you can just go ahead and see out something, something is wrong maybe. That's all. Let's go ahead and check our code. I guess now this will run fine. How many students are there? 5, 1, 2, 4, 5, 6, 7. Which value is to be entered? 7 is to be searched. The element is found. There we go, as simple as that. So we solved the problem, right? So what I wanted to do is I wanted to go ahead and try out the other way which I was telling you to. Just use that break statement and try to figure out a way to exit the loop if the element is found, right? So that's about the integer arrays. To deal with character arrays we need some other knowledge, right? So I'll tell you about character arrays in the next tutorial. That's it for this tutorial, guys. See you soon. Hello guys, welcome back to your ninth tutorial. Now in this tutorial I'll tell you a bit more about the integer array and about the character arrays, right? Character arrays are represented as strings. They are referred to as strings in C++, right? So what if I want to take my name and store it somewhere, right? So I cannot store my name in a single character because, well, it's not a single character, it's 5 characters actually. So what we can do is we can just go ahead and we can create a character array just like that, similar to the integer array. The declaration part is similar. All right, char name 20. Now if we try to use the for loop for reading the name, there won't be a problem unless we enter a space, because for loop the in statement does not detect a space, right? So if you enter a space, that the code will basically skip the rest of it and it will end, right? So that's the problem with in case of characters. So what we can do is we can just go ahead and use another function called puts or gets. There are two functions, gets and puts, just like we have cout and cin. Gets is for cin and puts is for cout, right? So for that we need to include conio.h, right? conio.h. So again we'll just go ahead, we'll write enter your name. Again we don't need to use only gets and puts in a program. We can use a combination of everything, right? Enter your name. Spelling mistakes again. So let's go ahead and use gets and store it in name, right? So this is the syntax of gets and the name of the array where it needs to be stored, right? Gets basically is get string. Okay, so that's what will happen. Again we'll write cout and l, your name is, we'll go ahead and we'll write puts of name. So let's go ahead and check if the code is right or not. Akib and your name is Akib, just like that. You know, that's basically what character arrays are. Okay, so now what if I want to store my name and a number simultaneously, like when I say 1 it should be my name, when I say 2 it should be the other person's name, right? So what we are talking about is similar to a matrix basically. You know what the matrix, right? A 2 by 2 matrix, or maybe 3 by 3 matrix. What happens is we have rows and columns. So maybe we have 1 2 3 4 as one column, and the 1 and keep 2 and your name, 3 and your friend's name, just like that. So again, when we write a matrix we write it in a two dimension, right? Matrix is the 2D figure. So that's what we can implement with arrays as well. Arrays can be one dimensional, two dimensional, three dimensional. There's no limit. You can even create a 10-dimensional array with, there has been no use detected for an array in more than 3 dimensions, but C++ does not stop you from thinking high, right? So what this basically means is when I say name of 0, I can store one name. When I say name of 1, I can store another name. When I say name of 3, I can store another name, and like that I'll keep going, right? So the number of characters here is basically the total number of names which I can put, and each name is of 20 characters, right? That's what it means. 5 by 20, a matrix of order 5 by 20, so in total there will be 100 characters, right? 20 into 5, each name having maximum of 20 characters. So that's the basic use in which you can implement various names in a single line. You don't have to create separate character arrays for all. You can just combine both of these two and create something, right? So yeah, I wanted to tell you something about matrices in this one, right? So the 2D arrays are mostly used to solve matrix problems, matrix addition, matrix multiplication and all that. So let's go ahead and just make a simple program to maybe add two matrices or something, right? So let me just make two matrices 2 by 2. I'll keep it simple. You can go ahead and try bigger ones. No one is stopping you to, right? And we'll need one more to store the final result, right? Again 2. That's it. So there are three matrices. Again we'll need a loop, two variables. So let's go ahead and ask the user, uh, enter the first matrix, right? So we'll need loops for taking the input. I is equal to 0, I is less than 2, I plus plus. You can also go ahead, you can ask them for the number of for the order of the matrix. So you can use I less than n or m. If they give a m by n matrix, you can have I less than m and I less than n and something like that. Okay, so j is equal to 0, j is less than 2, again j plus plus. Here what we'll do is we'll just take the input a of I and j, just like that, right? So what this basically does is for a general matrix, like 0 0 0 1 0 2, then 1 0 1 1 1 2, and like that, right? So we'll need the same exact loop for b. We can just go ahead, we can paste it right here, and we can write b, right? So we have taken two matrices. Let's go ahead and calculate the sum. So again we'll need this exact loop for that. What we'll do is instead of c in, we'll write c of ij is equal to a of ij plus b of I j, right? So we are storing the values in another matrix called C, and what we can do is we can just go ahead and see out that matrix right here, C of I j. Now this will not look very beautiful because it will just print all the elements in a single line. Anyways, let's go ahead and try it out once. There's no harm in trying. So there we go, 2 3 4 5. Did I not give the command for second? Okay, so this is the second matrix element, 6 7 8 and 9. There we go. The sum is something. As I said, it will not be very clear, but if you can see, 6 plus 2 is 8, so 5 plus 7 is 12, and it's working properly, right? So let's go ahead and try to make the output a bit more appropriate. So again, what we can do is we can just go ahead and enter slash t right here in double quotes and end l, end l. All right, let's try it one more time. Oh, wait, better let us also give the command to enter the second matrix, right? Enter the second matrix. All right, now we can go ahead and execute. Enter the first matrix, 2 3 4 5, 1 2 3 4 maybe. So that's where we get 2 plus 1 is 3, 3 plus 2 is 5, 4 plus 3 is 7, and 5 plus 4 is 9. So that's the output, right? That's what the two-dimensional arrays are mostly used for. So you can go ahead, you can try out subtraction, multiplication, making output a bit more beautiful. That's about it for the arrays. As of now, we have dealt with almost all the basics which are needed, and from the next tutorial we'll move on to a bit more advanced stuff like structures and classes, right? So I'll tell you everything about it. Just make sure you have learned everything I've taught you so far, because we'll be using all that which we have learned till now in a single code, right? We'll be using functions, we'll be using arrays, we'll be using if statements, maybe switch case, and everything whichever I've taught you till date, loops and all, the variable declarations, everything in a single code, right? Go ahead, practice a bit. I've added a few programs for you in this sheet attached, so go ahead, try them out, and I'll see you guys in the next one. Alright guys, welcome back to the 10th tutorial. So we are moving really fast, aren't we? Alright, so as I said, in this tutorial I'll be talking about structures, right? So as I told in the previous one, the major drawback of an array is that you cannot store different data types together, right? So structure comes in and solves that particular problem. Let me just define a structure, and then I'll explain. Structure is defined with the keyword struct, right? Struct stand for structure. You can give any name. Now suppose you are working in a company, right, and your boss wants you to make a program to take the details of, say, a few employees and display their salary or something like that, right? So what we can do is we can just name our structure employee, curly braces, and a semicolon. That's the syntax of a structure, right? Struct followed by the name of the structure, the curly braces, and the semicolon at the end. So in here we can declare the different data types which we want. We can say employee ID. We can use an array for the name of the employee, right? We can use another array for the name. We can use another array for the position, maybe 30 maybe is a supervisor or something like that. So that's what we can do here. So as you can see, we can have different data types. You can have float, you can have anything. You can have float for maybe the salary of the employee and all that, right? So this is the basic structure, right? So now what we have just defined is the basic blueprint of of something, right? So whatever we make, that is going to have all of these variables, right? So that is called a structure variable. Now again, there are two ways to define a structure variable. One is we can do that right here, employee 1 maybe, and employee 2, like that. Or we can just go ahead and we can just make an array of, say, 50 employees or something. Well, let's stick to 2 employees for this example, right? So this is the first way to define structure variables. Now what this is actually just like saying integer I. When we say integer I, 2 bytes of memory is reserved for that variable, right? So similarly, when we say employee 1, there will be 2 plus 50 plus 30, this 82 plus 4. A float is 4 bytes, so basically 86 bytes of memory will be reserved for employee 1, and again similarly 86 bytes will be reserved for employee 2. It's just like saying integer I. So integer I expects only one integer value, whereas employee 2 here expects these values, right? Now there's one more problem with structures. What that is, we cannot initialize the value here. We cannot just give it some value like 678 or something like that. That's not possible. We just we just declare the various data types which employee can have, right? So now to access those variables, what we need to do is we need to use emp1 dot name, right? So that's how we use it, the dot operator, right? Dot operator is used for accessing structure variables. All right, so now uh, I want to ask for the details, right? Enter the details for employee 1. Now since in this case I have only 2 employees, so I am not going to use a loop, right? So I'll go ahead, I'll say and L on name. Again, as I said, we can use gets for the name, so emp1 dot name, right? So for using gets we need conio dot h, right? So let's go ahead and write that conio dot h. Perfect. So semicolon should come at the end. There we go. Again we'll go ahead, we'll write what next, new line first, and then maybe id. So this we can just take it directly as it is an integer, so we can write emp1 dot id, and you can go ahead and you can take the other values to the position and salary if you wish, right? So that's the basic operation which you can do. Now again I can just copy the same code, I can put it again for the second employee. If you have you can you can make a array of employees if there are 10-20 employees, and you can again add a for loop with the this condition, right? emp I dot name and all that, so that you do at your own, right now I'm going to do it for the second employee, so I'll refer to as emp2 dot name and emp2 dot id, right? After taking the values, what I'm going to do is I'll just display the results. So here's what you entered. So go ahead, type first employee and name. So after the name, what emp1 dot name. Again, this is not the proper way, it should be emp1 1, that's right. Again I can go ahead, I'll say slash t id emp1 dot id, right? You can go ahead and write everything else for the employee 2 also. I'll just go ahead and save it, employee. Let's see if it runs properly or not. Okay, that's the problem. What we did is we wrote empid, right? So we'll have to write empid. Now instead of changing empid in all the places, we can just go ahead and we can remove emp right here, right? So name id. So there we go, here's what you entered. I mistakenly pressed enter here, so it did not took the name, right? So here's the details which I entered, right? So our code is working just fine. Now suppose your boss wants you to write a function to calculate their salaries or something, so you can just go ahead and make a function called salary. You can use this salary. Now since we have defined everything outside main, so everything in the structure is global, right? So that means you can operate it anywhere you want. Okay, so you can go ahead, you can take the salary, you can print the salary, you can calculate the whatever the basic and HR whatever is there in that. I don't actually know exactly. So that's what I mean. You can go ahead, you can create various functions using the structure elements, and you can perform various operations, right? So that's basically what a structure actually is. Now I told you there are two ways of defining these variables, right? One is you can do that here, which makes them global. The other way is to define them inside the main. For that you need to again write struct the name of the structure, which is employee, and emp1 or maybe 3, right? So it's similar to declaring integer a, right? Struct employee emp3. So what happens again is emp3 is allotted 86 bytes in the memory, right? So that's the second way to declare it. Now you can also have functions here in the structure, like a salary. Instead of declaring it outside, you can define it, you can declare it right here. But again, it's highly recommended defining them outside the structure, right? Also make sure you don't have conflicting names like this. Okay, so when we define a function like this, oh wait, this will be better understandable by the class concept. Okay, I'll tell you that in the next one. So that's basically what a structure is. It's a collection of various data elements, but there's one problem associated with the structure, which is obvious. I can access these elements from anywhere I want. There is no way to hide the data. Now, in the real world, the data is very sensitive, right? You cannot just go ahead and publicly allow anyone to access this data, right? We need some sort of privacy to, actually hide the data and to keep it safe, right? But structure does not provide us that. Now that is where the class comes in, right? So that's basically it for structures. We have used everything. As I said, arrays we have used. We can define functions for the structure elements, which I want you guys to do. I won't tell you that. Alright, so that's how you access the structure elements with the dot operator. Now that's basically what a structure is. It's a heterogeneous collection of various data types. It's basically a way to represent any real world object, right? You suppose if I'm talking about a fan, so I can write int number of wings, and the name of the company, and maybe the functions for rotating it and stopping it and all that. Just an example, you can write it for a hotel, bookings, reservations, number of rooms, all that. So that's the basic advantage. You can actually create the basic blueprint of a real world entity, right? Now since as I said, there are privacy concerns. Other than that, structure is basically very useful, but because of the privacy thing, the class has taken care of that. So struct is not used much except in data structures, which you don't need to worry about right now. So that's it about structures. Let me tell you a bit about another thing that's called union, right? A union, I won't actually write any code for that. Just I'm telling you the what union actually is, because we don't use it anymore. Since it's there, I think you guys should at least know about it, right? So what's the difference between structure employee and union employee? To structure employee, actually, there is no basic difference between them. The only difference is that when we create a structure variable, right, so it reserves, as I told, it reserves 86 memory locations, right? But in case of union, it will reserve the maximum memory size which is there in these elements. So if I declare a union of employee, so when I create emp1, it will only store the maximum size, which is 50 in this case. So it will only store 50 bytes in the memory, right? So what the problem in union is that you cannot access any element together, right? You can only access individual elements one at a time, because only one element is stored in the memory at a time, because it's not saving memory for all the elements, right? So that's the basic difference between a union and a structure. A structure stores all the elements separately in a memory, whereas union stores all the elements in the maximum size. So you cannot access two elements simultaneously, right? So that's the basic difference between union and a structure. Union is no longer used these days, but since it exists, so I thought you guys as well should know about it. So that's about it for this tutorial, guys. In the next one, I'll tell you about the class concept, which is the most important part of C++. So go ahead, try out a few codes. I have already attached them in the sheet, and see you guys in the next one then. Hello guys, welcome back to the 11th tutorial. So as I told you about structures in the previous one, I said that there is a major problem with the structures, and that is about the data security, right? So in this tutorial we'll be talking about classes. Now there are various things associated with a class and they are pretty advanced things, right? So I won't go into much of the advanced stuff, but I'll tell you the all the basics about classes, right? So similar to a structure, a class is declared just like that, with the keyword class, the name, and an ending semicolon, right? So that's exactly like a structure, right? Just we have class instead of struct. All right, so let's make a few elements, right? Marks, maybe character name 20 something, right? So let's keep it 2. All right, so now there is a slight difference between a structure and a class. In the structure, all the variables which we declare here are accessible from the main function using the object, right? So suppose I write student1, right? So if I go ahead and write st1 dot marks, I can access it, right, in case of a structure. But in this case, this statement is not valid, right? It will show an error. You can go ahead and compile and check yourself, right? So the problem is this variable is private, right? So there are three types of specifiers, right? So one is the public, one is protected, and the other one is private. Right, so the public elements are accessible everywhere in all the functions, right? The protected ones are used exclusively while inheritance. I'll tell you about inheritance in a while. And the private ones are basically can be accessed only using the member functions of that particular class. So by default, all the members in a class are private, whereas all the members in a structure are public by default. So you can access the structure members anywhere, but you cannot access the class members like this. One more thing, apart from the variables, we can also have functions inside a class. Same like we can have them in structure, right? So we can go ahead and we can write get data, one function, or maybe we can have another one as put data. Now again, as I said, by default these will be private. So if I try to access them using st1 dot put data, this will throw an error, right? Because it cannot access put data because it is a private function. So what we do is we go ahead and we write public. Whatever follows the public are public, have public scope, right? Now again, you can define these functions right here inside the class. I'll define one inside the class and one outside the class, right? So we can go ahead, we can type enter the details. So we can again use gets for name. We'll need to include conio for this. Mark, again we can see in mark. Now we don't need to specify the name of the variable here like st1 dot name, because this is a function which will be used by this object, right? So when we call it as st1 dot put data, it knows that it has to store it in st1 dot name, right? All right, so that's how you define function inside a class. Now what if I want to define it outside the class, right? So we have to specify the scope, right? So we'll write void the name of the class, then double this, and then we'll write put data. So what this operation, what this means is it's called scope resolution operator, right? So what this statement means is there is a function called put data which is for the class student. Now we can have several classes in a program, right? So suppose we have two functions named put data in two different classes. So how does the compiler know that which put data this definition belongs to, right? So that's how you resolve that problem. You tell the compiler that there's a class called student, and this particular definition of put data belongs to the that particular classes function, right? So again we can go ahead, we can write cout marks name is this and marks are this. Now let's I have made an object. Now this particular thing is called an object, unlike structure in which case it is called a variable, right? This is called an object. And let me just first show you how this program runs, then I'll tell you how to I'll tell you about the theoretical concepts, right? So first we'll need to take data, right? So we'll first call the get data function, then we'll call the put data function. All right, let's go ahead and try it out. Right, name is Akib, marks are 56. Right, there we go, name is this, marks are 56 exactly. All right, so now let me get to the theoretical part. compilers and interpreters are both basically check your program for errors, right? So compilers, what they do is they actually compile the entire program in one single go, while the interpreters do that line by line. So compiler first compiles everything in the program and then tells us if there are any errors, while interpreter, if there is any error in a particular line, it stops right there, it indicates the error and stops right there, right? So after that there are various programming techniques, right? So it starts from, right, so the first programming concept was it was executed line by line. The control was not shifted anywhere else. It started from the first line and it went on to the last line. After that, slowly the if kind of statements were developed so that control can be modified according to a particular condition. Then came the looping concepts and everything, right? So slowly after several years of programming, what we have today is this. Actually, this is also not the most modern thing out there. There are various advancements. So let me go ahead and tell you what a class and object exactly mean, right? You consider any real world object, right? So what a real world object can do, let us suppose maybe a tree or something, right? So tree has roots, tree has leaves, tree has stem, and all those are its parts, right? And what it can do is it can shed its leaves, it can regain its leaves, and those are its characteristics, properties. Or suppose we consider a bike, right? So there are various parts like handle, seat, and etc. And what it can do is it can start on its own, it can accelerate, it can brake, right? So what I'm implying is that there are a few characteristics and there are a few properties, right? So the characteristics which make up the actual body are the variables and the properties are the functions. That's how the real world objects are represented in programming, right? So a class is basically the blueprint of an object. So if I say class student, I mean a particular student, as in a real world student, right? So what a real world student has, a real world student has name, a real world student has marks, and maybe the academic history or something like that, address, phone number, and all. And what it can do is I can write various functions to calculate the total marks, the average marks, and all that. So that's how a student is represented in a programming language like C++, right, by using a class. Now there are various concepts associated with a class. Alright, so class is basically the major difference between C and C++. C++ is basically C with classes. There are few things like abstraction. First concept is abstraction. So what abstraction basically means is a blueprint of something which has some functions of its own, right? So that's what we do here. We have a blueprint of a student and the functions associated with it. So the user just cannot write any function of its own, right? We have given some predefined functions for him to use. So as of now in this program, the user can only use two functions. One is get data and put data, because only those two we have made available for the public, right? So the public can access only those two functions. They cannot access the marks and name directly. They can do that only via these two functions, right? The next concept which comes into play is encapsulation. Now encapsulation basically refers to the binding together of a data, right? So suppose we are riding a bike, so we don't actually know when we switch the gear by holding the clutch what actually happens, right? We don't know the inside machinery stuff. What we know is when we press hold clutch and shift the gear changes, right? That's all we are supposed to know. So that's the basic concept of data hiding and encapsulation. Only whatever is required for you is visible to you, right? So in this case, we only the functions are visible to the user, right? How the data is stored and how much memory is allocated for that data and all, that is not required. Just like in a case of calculator, you don't know how the actual calculation takes place, but you only know to give the inputs and get the result, right? That's what we want. We have no interest in knowing how it actually calculates the stuff, right? So that's what data hiding and encapsulation means. Another concept is polymorphism. Now polymorphism is basically one same function having different outputs according to the different inputs, right? So suppose we have a class called bird and we pass a function called seeing at night, right? So all the other birds will return false, but the owl will return true for that function. So that's what polymorphism basically means. One same function, different outputs depending on the inputs, right? So those are a few concepts associated with object oriented programming languages, right, like C++. And class is basically the implementation of all those concepts into programming, into C++, right? Alright, now there are a few other advanced stuff in class like inheritance and all, which I'll not show you in this tutorial, but I'll just give you a hint of what that actually means, right? So inheritance is basically like one class can inherit its properties from another class. It's just like real world inheritance. You inherit some of your characteristics from your father, some from your mother, some from your grandfather, like that, right? So exactly what we can do is we can create a class called vehicle, right? Vehicle, we can give its properties like it has some wheels, engine and all. And then what we can do is we can go ahead and we can create another class called a car. So we can narrow down our characteristics to vintage or SUV and all. Then again we can create another class for a particular car. So suppose if I say Tata Fortuner, right? So what I'll do is I'll inherit the properties of vehicle as well as SUVs, and then I'll add its exclusive features to the class of a Fortuner, right? So I don't need to define it as a vehicle again, because I can directly take the properties of vehicle and put it directly to that class, right? So that's what inheritance basically means, taking the properties of a predefined class and specifying only the extra properties which it has, right? That's basically what the class concept is. You will mostly use class concepts for professional programming. So that's about it for the advanced stuff. From the next tutorial onwards, what we are going to do is we'll start making our own snakes and ladders game, right? So go ahead, try out a few codes. I have given them in the sheet, and I'll see you guys in the next one then. Alright guys, welcome back to your 12th tutorial. Now as promised, from this tutorial onwards we'll be making our very own snakes and ladders game, right? So as you might already know, there are many compilers available for C++. Till now we have been using Dev C++, but there's one problem with Dev C++. It does not seem to function properly while dealing with graphics, right? So what we are going to do is we'll go ahead with Turbo C++. Now Turbo C++ is the one in which I originally made the snakes and ladders game, right? So here's the link. Go ahead, click on Turbo C++ and hit download button at the top right. Your download will start automatically. The installation is very basic, so download it and install it. You don't need to do anything else. After you have installed, you will get an icon on the desktop, and just go ahead and open it, right? So as I told you already, I originally made several different programs, right? So I made a program for the first screen. I labeled it as home.cpp. Then I made another program for the second how to play screen, right? Then I made another program for the board which was there in the final thing, right? And then I copied all of these programs and I made a final C project thing, right? So I'll what I'm going to do in this and the next tutorial is that I'll not actually write anything. I'll just guide you through the original code, right? So it will save both our time. All right, so let's get started then. In this one we'll be dealing with home and how to play, and in the next tutorial we'll be making the actual board and finalizing the project, right? You already know about iostream.h and conio.h. Right now stdio.h stands for standard input output. This is needed for this function right here. It's called clr for clear screen. Whatever text or whatever is on the screen, this function clears it. If suppose we have something from previous function or something, so this will clear everything, right? Then graphics.h. Now obviously since we are dealing with graphics, we need to use the graphics functions. The best part of C++ is that almost all the functions which are needed for graphics are already predefined, so we do not actually need to create separate functions for everything, right? So next thing is GD. Now this line and this line, they are the basic prototype of the graphics program, right? So whenever you want to make a graphics program, just go ahead and type the first and the third line, right? That's the basic syntax. Now GD stands for graphics driver and GM stands for graphics manager, right? So detect is another keyword which tells this GD to start functioning, right? Now init graph is initialize the graph, Graph basically represents a 640 by 480 screen in Turbo C++. So we'll pass the address of driver and manager and the location of the BGI file. Now BGI file is what actually contains the basic graphics, basic graphics, right? All the functions in this particular header file. Okay, so let's begin then. Set bk color here stands for set background color. Bk is for background, and whatever color we give within these brackets is set as the background color. Now make sure guys, C++ is case sensitive, right? So if I write red in capital and I write red in small, so there's a big difference in both the cases, right? Now set color. Now set color is basically it initializes the color yellow for all the statements which follow it till we put another set color, right? So what will happen is all this text here which we're going to print will be in yellow in color, right? So set text style basically is to modify the text style. This is font, this is the location of the text, and this is the size. Now let me tell you one cool trick. Just go ahead, hit the help menu and hit index, right? So it is set text style. Just go ahead and type set text style, right? There we go. Just double click on it, and this is the best part about Turbo C++. You can actually get to see all the details about this function. So it tells us that set text style is a function which is in graphics.h, right? And this is the declaration. The first thing which we write here, that is 8, is the font, the direction is 0, and the size of the characters is 7. Alright, now it's confusing. How is the direction 0? Just scroll down and you will get the answer, right? 0 is for horizontal and 1 is for vertical direction. So since we are going to print it in horizontal line, so we'll put 0, right? Again, you can have different character size values. We have put 7 in this case, up to a limit of 10 times the normal size. There we go. So as our text is basically going to be 7 times this particular text, right? It even gives you a sample program to try out, so that you get to know about the function. So that's the basic thing about Turbo C++. You can go ahead, click index and search any function you want. You get everything related to it. All right, so that means the font is whichever font is defined at 8. You can find a list of the fonts again from the help section. 0 is for horizontal and 7 is the size of the text. Now instead of cout in graphics, what we use is out text xy. Now as the name suggests, out text will basically print the text and xy are the coordinates. So this line will print the text at 25, 50 in a normal graph point, normal mathematical graph, and it will print snake starting from this point till whatever the length is, right? Similarly, this will print an ampersand symbol, or basically and, at this location. Again, this will print ladders at the point 325, 250. It will start from there and go ahead, right? So that's basically for snakes and ladders. Then again we are changing the color to cyan for the snake, which is a shade of light blue, so something like this one, right? Then set line style, again solid line, line width and size. You can go ahead, you can again check the help section for this. Set line style, there we go. See, line style, it's up pattern and thickness. Again, you can scroll down and you can find what actually the style and all represents by this example. All right, so just go ahead and see, have a look at it. Now arc is basically for I'll show you what arc is for, right? See, the snake, our snake is actually two semicircles, right? So that's what arc is for. Arc is basically in this case I am using it for semicircles, right? So here's one arc, then here's another arc. All right, the first one is a bit thicker one, as you can see in the output screen. The circle is for its neck, and the line is its mouth basically. Again, put pixel is its eye. Put pixel basically highlights one particular pixel. So these are the coordinates of the pixel, and this is the color of the pixel which needs to be highlighted. Again, line is x1, x2, y1, y2, basic mathematical coordinates. Circle is the coordinates comma radius, right? So the best thing to work, do while working with graphics is to actually take a sheet, draw a graph, and draw everything which you want to make in your program, and literally calculate the coordinates manually and then put them in. That is the best way to do it. What we did is we took a A4 A3 size sheet, we drew the entire 640 by 480 pixels graph as big as we could, and we made all the snakes and ladders, and we wrote all the coordinates of its mouth, tail, and everything, and then finally we wrote this thing, right? So if you do that properly, this will basically save your time for finding out if the circle went somewhere else, if the mouth is on the tail instead of the neck and all that stuff, right? So it's basically pretty interesting to make all this, provided you have a lot of time to do it, right? Because it's a lengthy process, which I'm sure you have, right? So go ahead and maybe you can write your name on the screen with different fonts and sizes or something, right? Again, to draw the line is basically the ladder in this case. So set color, again we'll change the color to green, and again x1 x2 y1 y2 x1 x2 y1 y2, there we go. So one we will draw two lines, two vertical lines and three horizontal lines, right? So after we have made all these lines and all, what our code will be is, obviously it will look like this thing right here, right? So there's the ladder in green, two vertical, three horizontal lines, the snake with one circle, one line, one pixel, and two semicircles, and the text snakes and ladders, and the background color is red, right? So that's what this code is going to do. Alright, so now that we are done with the home screen, let's move on to how to play screen. Now how to play screen is, we basically kept it very simple, right? As you might have seen, I'll show you to you once again. That's basically the how to play the game screen, right? So in this we haven't used any graphics, right? It's just simple see out statements. Just to make it a bit interesting, we have just used underscore here for the line and everything, right? We have put a few slash in here to make the note thing appear at the bottom. So because working with graphics is a very tedious and lengthy task, so you can even use simple cout statements to make your job done, right? So that's what how to play screen looks like. Let me just quickly revise it once again for you guys. Set bk color is for the background color, a gd is graphics driver, initialize graph command. What initialize graph does is it basically starts the graphics thing, right? Then again, set color is for whatever color you want in the statements following it. It will be that color unless and until you change this color by using another set color thing. So there we go, that's basically it for this screen, right? So now that you have a clear idea of how these two screens are made, I recommend you to go ahead and try out this code, right? So in the next tutorial I'll tell you how we actually made the checkerboard for the numbers and everything, and then I'll tell you how to make that a die appear on the space and random number generation and all, right? So that's basically it for this tutorial. Go ahead, try this thing out, try a few graphics, try displaying your name etc on the screen, and I'll see you guys in the next one. Alright guys, welcome back to your 13th tutorial. So in the previous one I told you about the home screen and the how to play screen, right? So in this one let me tell you how to actually make that board, right? The board which will actually play the game. So let's go ahead and see what our output is going to look like. So that's what the board looks like. It's a 10 by 10 board with 5 ladders, 5 snakes, 1 pointer, default location is 1, and the controls on the right hand side, right? So as I already said, it's better to plot the board in on a real graph and take down the coordinates before actually starting working on it. So all these things right here. So only one thing is new, that is the set viewport. Now what our code requires is that with every encounter of a die we need to refresh the board, right? With every new number we need to move the pointer and we need to refresh the board. So what set view board basically does is it sets the area which is going to be refreshed, right? So our board starts from 10 10 and it goes to 200 200. So we basically select that much area for refreshing. So there's another function which refreshes it. We'll get to it after a while, right? So here's the code which we wrote for making the checkerboard, right? So basically it was my sir who wrote this and the numbers thing. So we'll start from 10. Right, counter 1 will put it as 10. So 10 10 is our default location, which is counter 1 and counter 2. X1 X2 is 0. So what set view board basically does is it treats 0 0 as 10 10, right? As per its own dimensions, it works on its own dimensions, right? So we have made 40 by 40 squares, right? So we'll start from for the 0 0 thing and we'll increment 40 every time, right? There we go, we'll increment 40 every time. And thus this will make the box, right, a 10 by 10 box. Or else you can go ahead and you can create so many lines, which is a very hectic process, right? There's another function here called rectangle, again x1 y1 x2 y2. That's how we made the 10 by 10, that's 100 rectangles. So either you can sit and you can make 100, you can put in 100 coordinates, or else you can make a loop for it, right? That's where loop comes in, right? We have to repeat one particular thing many times. So we'll increment the values by 40 every time, and we'll take this to 10 times, right? Counter 2 is 10, so counter 2 minus minus will take it from 10 9 8 7 6 5 4 3 2 1. So this code will run till counter 2 reaches 0. So basically this will run 10 times, so it will print 10 rectangles. Again counter 1 will run from 1 to 10, and each time it will print 10 rectangles, so that makes 100 rectangles, right? All right, so that was for the board. Now again, easy ways to just write the numbers 1 2 3 4 by different out text xy statements, because you will not get the this loop right now. Okay, but still I'll give it a try. For left to right, what we basically did is we increased the thing by 40 40, and we started from the middle, right? X1 plus x2 by 2 and y1 plus y2 by 2. So we displayed all the numbers starting from the middle of the first box to the end, or to the middle of the last box, right? And since the size of the box is 40 by 40, so obviously the location needs to be, the coordinates need to be incremented by 40 on everything. Again this runs 10 times, right? And again this runs 5 times, because if you look at the board properly, 5 times we have to start from 1 on the left hand side, right? Like 1 11 and all. And the let me show you, right? So as you can see in the first one, it starts from 1 to 10, then it goes from 11 right above 10, not from the, not 11 is not above 1, right? It should be above 10. So that's what we do. We made two different loops for that. One loop prints 1 21 41 61 81 and that line, and the second loop prints 20 40 60 80 100, that particular line, right? So this loop here, which says left to right, is basically for printing the 121 41 thing, and the right to left thing is for printing 11 31 51 and that part, right? There's no difference between these two loops, just the value is, if in the first case we incremented by 40, in this case we'll decrement by 40, because we have to move in the opposite direction, right? Again, to insert file adders, what you can do is you can just go ahead and make 5 different lines, right? 2 vertical and 3 horizontal lines. Or else you can go ahead and try it using a loop, in just increment the values of the horizontal lines, because you can draw vertical lines manually, and you can use, because you have to make 3 horizontal lines, so you can go ahead and you can try loop for that. Just we have just decremented it by the values, so that we start from the first one, then we come down the second line, then we again come down in the third line, right? Or else you can just go ahead and you can write 3 different line statements. Then again snake includes 2 arcs, just like the one we made in the previous home screen, right? So that's basically all in this code. Snake 3, snake 4, snake 5, ladder 2 3 4 5. That's what I said. It's easy for us to actually write 5 ladder statements then using that loop, because again we'll have to write 5 different loops because the location of ladders is random, right? Again, to display the controls, we'll use outText XY. The controls are on the right hand side of the screen. Now the player is basically pi slice. Pi slice is basically a circle, a filled circle, right? So that's the location, coordinates x1, x2, y1, y2, and the radius. Get ch is for this, and close graph is to close the graph which we started using init graph, right? So initializing the graph and closing the graph. So that's how we actually made that box, the board, the actual game board, right? So now let's go ahead and I'll show you the final project which we actually submitted, right? So as you can see, there are two different files. The first one is dos.h and the second one is stdlib.h. Now dos.h is basically for using the time function for the delay functions, right? So we played saregamapa in the beginning, right? So that's what the dos.h is for, and this stands for standard library. I'll show you what it is for, right? So again, as I said, we just copied all the codes which I showed you till now into separate functions. So the first function, right, as you can see here, we have 1 2 3 4 5 6 functions, right? So the first function is for the saregamapa thing, the second is for the home, the third is how to play, the fourth is board, and the fifth one is for random number generation, and the sixth one is for the final screen where we actually take the input, right? So let me show you one by one. The sound function. Now what this particular is the frequency. So what we did is we googled up the frequency of saregamapa and we just used it, right? The delay which is defined is dos.h is basically for making that particular sound run for 500 milliseconds, all right? So that's what it's for, and every sound needs to be stopped by the no sound function, right? Or else it will keep on playing it. So then this I showed you already for snakes and ladders, then instruction display function, then the board function, everything is the same. Just to make it a bit more easy for us, we use different programs to first make all the components and then we combined everything into one code, right? Now the die should generate a random number every time, right? So for in C++ there's another a function called randomize. So this is available in stdlib.h. What it does is it generates a random number between the range which you give it, right? So that's the range. I should start from 0 and it will be till 6, right? So this is basically the syntax of the random function. You can just go ahead and help and check. I'll show you random, right? See, it's available in stdlib.h. The two functions, random and randomize. Randomize basically generates the number and random is used to set the range, right? Right. So random returns a random number between 0 and num minus 1. So that's what it does. So between, we'll need the range between 6 and 1 and 6. So what we did is 1 and num minus 1. All right. So that's what the random function works like. Okay, then we'll be returning this value to the main function. So since we are going to return an integer value, we have declared the return type of this function as int, right? Now function for taking the input. There are two options, right? Space for rolling the die and E for exit, right? So again we'll start a while loop because the for loop will not work in this case. So we'll use a while loop if the input is not equal to E or E, just to make it a bit more user friendly, because I don't know that I should press shift and E or caps lock and E. My code does not know whether the user is going to enter capital E or small e, right? So whichever E, until and unless the user enters E, it will keep on running this. So what we'll do is we'll set the value of input as get character, all right? So a get che is for one particular character, all right? So if the input is space, we'll just call a random number generator function. We'll store a random number and we'll print that particular number on the screen, right? So we'll say the die shows and that particular number. This is for converting this into a string, right? Because outText XY works only with strings. so we'll need to convert a number into a string, right? So that's how we do it. We take one string and we store our number in that string. All right. So again, we'll use outtext xy and we'll show the die shows and that a number which we took, the random number which is generated just now, right? We'll delay it for a few times so that you get the feel of the random number being actually generated. All right. Else, if the input is e, we'll take it to the another screen and we'll use clear device. So it will basically clear that particular viewport and it will take us to another screen where we'll print, are you sure you want to quit? With two choices, yes or no. Again, if the choice is yes, we'll exit the program by using the exit function. Exit 0 basically quits the code and comes out of the program. And if the choice is n or n, we'll just ask them to press any key to continue. So if they press any key, then we'll just go ahead and we'll call our board back again, right? So that's how this code will work. Now again, this is as simple as my main code looks. All right, I don't need to call it every time, right? So what this is the basic graphic syntax which we need, right? So what else do we have here? We just have the home function first. After that we have the how to play function. After that we have the board function. Just three functions, because the random number generator and everything else is taken care of in the board function already. All right, so as I said, keep the code of main as simple as possible, so that's as simple as it can possibly be, right? So that's what the game basically looks like. That's how it is made. I just it's not possible for me to write this long code and guide you through the everything. So that's the best way I found to teach you this particular thing. I guided you through the entire process. Let's just go ahead and try it out one final time. There we go. Yes, spacebar to roll the die. Let's hit space. The die shows 3. There we get a pointer on 3. All right, again the die shows 6. 6 plus is 9, so there we get it on 9, right? E to exit. If I press N, it will just ask me to press any key and it will take me back to the board. Again, if I press Y, it will take me out of the game. Alright, so that's what snakes and ladders actually is. That's what how you can make it.